Guys, so today we're talking about 1.4 solving absolute value inequalities. So we're going to go through how to set these up. First, let's talk about equations that we already did. So remember, when you have an absolute value, you need two equations. Just like how we already set these up with one positive answer and one negative answer. So remember, we have our answer here. We don't know what that is, but it's set equal to a positive. And then the same thing with a negative. So that we already learned and we know how to do that. But let's talk about if we have an inequality that's absolute value. So when we're working with inequalities, we need two. Just like we did with the equations. But this time, if we're given an inequality that has a less than or a less than or equal to, I like to say it's less and. That means we're going to set up an and inequality. It turns into that compound. So we call it less than. Kind of sounds like than still, but we have that D at the end. And remember, our and inequalities are graphed kind of like that, where you shade in the middle. When we set these up, it's going to look something like this. We're going to have our number, our less than, the answer, and our number in the opposite direction with the opposite answer. Sorry, I write too big. Most of you know that already. Okay, and I promise this is going to make more sense once we do the examples. Now let's look at greater than. What we like to say is greater than, because when you're given a greater than sign, it turns into an or equation. So greater than. When you graph those, they look something like this. You have either your open or closed circles, but it's shaded on the outsides. So you would have, a number, your sign, the answer, or your number, the other sign, opposite answer. Again, I promise it'll make more sense once we do it. Okay, so let's do these examples. Just like you started with absolute value equations, you need to get the absolute value all by itself. So for A, the first thing I'm going to do is add 4 to both sides. When I do that, the 4's cancel, and I'm left with the absolute value of x plus 2 is less than 7. So I said less than, let's look up. Less than is an and equation. So I'm going to make this into an and equation. So what I'm going to do is I'm going to rewrite this exactly the way that it's written. X plus 2 is less than 7. Then I'm going to write a big and in the middle. And I'm going to write x plus 2 again, but this time I'm going to go the opposite direction with my sign, and it's going to be a negative 7. So that's what this is telling you up here. So this one, exactly the way that it's written. This one, the sign flips and it becomes a negative. Now we can solve. So if I was going to solve these equations, I'm just going to subtract 2 from both sides. I get x is less than 5. I'm going to keep my and in the middle. Do the same thing over here, subtract the 2. And I get x is greater than negative 10. Now, when we talked about and compound inequalities, we usually just had that letter in the middle. So this can also be written, sorry, this is supposed to be a 9, oopsies, negative 9. So when you have that letter in the middle, you can rewrite it. I have my x in the middle, I have my smaller number on the left, my bigger number on the right, and I put in my signs. Remember, it eats the bigger number, so it should look like it's eating that bigger number, that 5. This right here is your answer. And now I'm just going to graph it. So I'm going to have -9 over here, 5 somewhere over here. These are both less thans, so it's open circles. And we know that in and you shade in the middle. Okay? All right, let's do B. So B has a different sign. It's greater or equal to. My absolute value is already by itself, so we don't have to do any other work, and we know that since it's greater, this is going to be an OR equation. So I'm going to start out by writing this exactly the way it's written. 2x plus 7 is greater or equal to 8. I write my OR in the middle. Then I have 2x plus 7. Flip that sign around and make it equal to a -8. So far, so good. Now I'm just solving. So first I would subtract the 7 to solve. I get 2x is greater than or equal to 1 and divide by 2. So we get 1/2 or 0.5. Then I'm going to write my OR in the middle. We know that when we have OR equations, we always see OR in the middle, so I'm going to make sure I write that. And I'm going to do the same steps over here. So subtract the 7. 2x is less than or equal to -15 and divide. So x is less than or equal to, we can leave it as -15 over 2. Now, if I looked at these, I want to make sure that they're in the right order. I have a negative over here on the left, and I don't like that. I like to make sure it goes from least to greatest. So I'm just going to rewrite this for my final answer with the -15 over 2 first and the 1/2 second. So that right there is how I write my final answer. Now let's graph it. Since I already put it in the correct order, I know that -15 over 2 goes over here. 1/2 goes on the right. They're both going to be closed circles because of that equal to, or that little line underneath, and they're shaded on the outsides because it's an OR problem. All right, we got 2 more. Over here, my absolute value is all by itself, so that's great, no extra work. It's less than or equal to, so it's going to be an AND problem. And I'm going to show you another way we can set up an AND problem. So I have my absolute value that's in the middle, 3x minus 5. I'm going to have my less than or equal to 10 over here. And then I can put my -10 on the other side. So this looks just how, our final answer does over here. You can set it up like this if you want, or you can make it 2 separate problems. It's totally up to you, same thing. Now I'm going to just solve for the middle. So first, add the 5s. So I have -5 less than or equal to 3x less than or equal to 15. Last step is to divide. So right here, this is going to stay as -3/5. I have my x in the middle all by itself. That turns into just a 5. So like I said, some of you may like setting it up like this right away better. Some of you may like to see it written out this way. It's totally up to you. Whatever you guys think is easier. Make your smaller number on the left, bigger number on the right. It's less than or equal to. So we have those closed circles. And it's and, so we always know shaded in the middle. Okay, last one. So this one does not have absolute value by itself. So the first thing that I need to do, divide both sides by -2. When I do that, I have the absolute value of x plus 3. I divide it by a negative. Remember, when I divide by a negative, I have to flip that sign. And that turns into a 4. So when I started this problem, I saw that it was a less than. So I might think it's going to be an and problem, but I have to get my absolute value by itself first before I can decide. So my absolute value is by itself, it's greater, so it's going to be an or problem. Now I can set this up. X plus 3 is greater than 4, or x plus 3 is less than -4. Then you subtract. Over here, x is greater than 1, or x is less than -7. But I'm mad because my smaller number is on the left, so let's rewrite that. My final answer should look like this. This is how they want it typed in Buzz. That's why it's important to make sure that this is your final answer. I'm going to make that note Buzz right here. That's what Buzz wants. So my -7 on the left, 1's on the right. These are open circles, and we're shaded on the outsides. All right, guys, let us know if you have any questions. We hope you have a great day.